Okay, the following is a video over 5 notes, and this is a section about inequalities in one triangle. Before we talk about what's going on in the triangles, I do want to talk about this word inequality. Okay, and an inequality, okay, let's write that up here. An inequality means that things are not equal. Okay, it's when quantities are larger or smaller. Okay, and so what I want to do is I want to take a look at this picture of the triangle that we have, and I want to note that what I have here at angle 1, this is the exterior angle. Exterior angle. Okay, and I'm going to draw in angles 2 and 3 here. Okay, and what I know about this is that if I have an exterior angle, so if angle 1 is exterior, all right, then I know that angle 1, okay, is greater, the measure of that is greater than that of angle 2, okay, and, all right, and angle 1 is greater than angle 3, okay? So, and that's just going to be kind of pretty standard, so we can figure that stuff out. So this is the exterior angle inequality, okay? And so then I want to talk about the inequalities. So inequalities of lengths of the sides of a triangle, okay? And what I want you to do is to draw a scalene obtuse triangle. So I'm going to draw in a triangle that has an obtuse angle and a very long side like this, okay? And so you can kind of tell which sides are longer, and or maybe which angles are bigger. Okay, so let's just go ahead and call this angle here. Let's call this angle A for starters, and I'm going to say that angle A is 120 degrees. Okay, and then I'm going to call this angle B over here, and I'm going to say that angle B is say 40 degrees. Okay, and then what I know over here at this angle, I'm going to call this angle C. And if this angle is 140 and this angle is 120, that adds up to 160. So then I know that this angle over here has to be 20 degrees. Okay, so what I know about these triangles, or this triangle, is that my angle of 120 degrees is across from the longest side, okay, longest side, okay, and then I know that my shortest angle, or my smallest angle, is across from the shortest side, okay, so I'm going to draw one over here, and this is my shortest side, okay, and then I'm going to call angle B is my middle measure angle, okay, and that is across from the middle length, okay, and so and that's going to be true for all of them. So I know this, that if angle A, okay, is greater than angle B and is greater than angle C, let me put angle measures in here so we kind of can differentiate between those. It's greater than angle C, okay, then I know that AB, segment AB, is going to be larger than segment AC, okay, and that is going to be larger than segment, oh wait, let me erase this. This should be segment BC, sorry. Sorry. Okay, BC is greater than AC, so BC is greater than AC, which is greater than AB. Okay, and so the key to this is that for us to write over here that the longest angle, or the longest side rather, is across the the largest angle. Okay, and that the smallest side is across the smallest angle. Okay, and vice versa. Okay, and the middle is across from the middle angle. So that's what we can tell from the sides of a triangle. So let's go ahead and answer some of these questions here and use the exterior angle inequality theorem. And so let's write that up here, that this is the, I forgot to do that this is the exterior angle inequality. Okay, and so let's go ahead and come over here and it says, use inequalities to list all the angles that satisfy the stated condition. Okay, so I want to know in this number one, angle measures that are less than angle 1. Okay, and so what I know from this, and this is kind of interesting. Okay, I know that angle 1 is an exterior angle to pretty much all of these other angles except for angle 9. Okay, I can say that angles 2 and 3 are going to be are interior angles to angle 1. I know that 4 and 5 are interior angles to angle 1, and so is 7 and 8. Okay, you can probably make a claim for angle 6, but that doesn't satisfy our theorem. We could show that, but let's go ahead and come here and say that we've got angles that are less than angle 1. So I know that angle 2 is, I know angle 3 is, I know angle 4, I know angle 5, angle 7, and angle 8. Okay, or less than angle 1. Okay, let's take a look at the next one where it says less than the measure of angle 9, and it's pretty similar to that, but we got to think about what we're guaranteed by what we had said previously. So here's my exterior angle 9. I know that 7 and 6 are interior angles. Okay, I know that angle 4 is going to be less than angle 9, and so is angle 2. So I can only say a few of them here, but I could say angle 2. I could say angle 4. Let me put an angle symbol there. Okay, angle 4, angle 7, and angle 6. Okay, that we are guaranteed to have less than that. Okay, the next one is which measures are greater than angle 5. Okay, so angle 5 is located right here. Okay, which ones are going to be greater than angle 5? So angle 5 is an interior angle. Angle 3 is an exterior angle, given that, and so is angle 1 is an exterior angle. So what I can say here is that angle 1 is greater, and so is angle 3. Okay, the next one that I've got that I'm guaranteed to get is which is greater than angle 8. Okay, so angle 8 is right here. And so it's right here. I know that angle 5, angle 3, and angle 1 are all exterior angles, given that angle 8 is an interior angle. And so let's go ahead and just list those off, angles 1, 3, and 5. So angles 1, angle 3, and angle 5. Now we could probably make some claims that there are other angles, but I'm strictly basing all of this on the exterior angle inequality, okay, which is what we've listed up here, okay? So we have to be able to identify which is our exterior angle and which one is our interior angles, angles 2 and 3. So that's how you answer questions like that. Okay, let's go ahead and take a look at list the sides list the angles and sides of each triangle in order from smallest to largest. So I know that let's go ahead and list the sides, okay? And so if I were to list my sides from smallest to largest, I would say RP is my smallest, okay? I would say that is less than, or we don't have to put that, we can just list them out from smallest to largest. So RP is my smallest, PQ is my middle, and then QR is my largest, okay? And then let's do angles, okay? And so my angles go from smallest, which would be angle Q, okay, that's across from RP, that's across from 2. Angle R is across from segment 5, which is our middle length, so angle R. And then our last one, which is angle P, okay? All right, let's take a look at number 6. Let's go ahead here. The first thing I want to do is to figure out what this third length is, angle M, or angle the length of, or the measure of angle M. So angle M plus 24 plus 98. Okay, if I add all those up, I'm going to get 180 degrees. So I can find angle M. So if I solve this, I get angle M plus 122, combine my like terms of 24 and 98, set that equal to 180, and then subtract by 122 on both sides. And that's going to give me that angle M is equal to 58 degrees. Okay, so I know that this is 58 degrees. Okay, so let's go ahead and figure out the order in which our angles go. So let me write angles here. Okay, and I'm going to say that angle K is the smallest, okay, because it's 24 degrees. I know that angle M is the next one up because it's 58. And then I know that angle L is the next one up because it's 98, okay? And if we did our sides, then I would say from smallest, that'd be segment ML because that's across from 24. Okay, so I'm going to say segment ML, okay? The next one up would be segment KL because it's across from the 58 degree angle. So I'm going to say KL. And then I'm going to say segment KM because that's across from the largest angle of 98. Okay. And that's what I've got, and that's our answer. Okay, let's take a look at number 7. Okay, number 7 gives the side lengths again. And so what I've got here is I'm going to measure our sides first. Okay. And so my smallest is HG, it's 9. Okay. And then my next smallest is FG. Okay. And then my next largest is FH. Okay. So if we did our angles, okay, so my smallest side length is HG. That's going to be across from angle F. So I'm going to say angle F here is my smallest angle. My next largest side is FG, and that's across from angle H. So angle H is my next largest angle. Okay, and then I know that FH is my largest, and that's across from angle G. So I know that angle G is my largest angle. Okay, all right, let's take a look at the next one, number 8. Okay, and I know that in this triangle, I've got a 90-degree angle here. This is 42 degrees. So I can do this. I want to find angle B, and I would say that angle B plus 42 degrees is equal to 90. Okay, I could use the whole 180 concept, but because I know this is a right triangle, I know that these two angles have to add up to 90. They're complementary. So I'm going to go ahead and just subtract 42 from both sides. And so I end up getting that angle B is equal to 48 degrees. Okay. And so then I'm going to label here that this is 48, and I want to label my sides and my angles from smallest to largest. Let's go ahead and write out our angles from smallest to largest because we have those numbers. I know that angle A is the smallest, okay? Angle B is the next smallest, and then angle C is my largest. So if we were to kind of translate that to the side lengths, then I would say that my sides go from segment BC, okay, because it's across from my smallest angle. So I'd say segment A, or I'm sorry, CB. CB is my smallest. My next smallest is going to be CA because it's across from my medium-sized angle. So that's segment CA, okay? And then my largest side length is going to be BA because that's across from my 90-degree angle, okay? So I'm going to say that that's BA, okay? And so that's it. Pretty simple stuff, but you just kind of got to make sure you know what you're doing. Hopefully you enjoyed this video, and I had a lot of fun making it.